Mhm. Good afternoon, everyone. My name is Aruba Chaudhary, and this is my final project. The topic I chose was traffic incident severity predictions using machine learning. In this project, I used the real US Department of Transportation's crash data to build a machine learning model that predicts the severity of fatal traffic accidents. I will walk you through the data sets and my preceding process steps and the model, my evaluation results, and then finally I'll show you a demo of how the predictor works. Oh. For this project, I used the official FARS dataset, the Fatality Analysis Report System. This is a government database that includes every fatal crash in the United States. It contains details like time and date of the crash, road type, lightning conditions, weather, rural versus urban location, and how many fatalities occurred in each crash. I downloaded the accident.cvs, CSV file and use that as the main input for my model. Hmm. The main question I wanted to answer was, given the conditions of a fatal crash, can we predict whether it is likely to be a single fatality crash or a multiple fatality crash? So I turned this into a binary classification problem. 0 equals one fatality, 1 equals two or more fatalities. The goal is not to predict accidents themselves. FARS only contains fatal crashes, but instead to classify the severity of those fatal crashes. To keep the model realistic and simple, I selected a set of meaningful features including hours of the day, month of the year, whether the area was rural or urban, weather conditions, lightning conditions, road functional system, and road ownership. I also engineered two small features. Um, is night true? Is night is equivalent to true if the crash happened late at night, or is winter is true if the crash had happened during the winter months. These extra features gave the model a little more context about like the environmental conditions. For proceeding, I had to do several for pre-processing, I had to do several things. Remove invalid hour values. Bars labeled unknown hours as 99, so I had to take those out. And then one hot encoded all categorical variables, create the binary target variable called high fatal, build and engineer features, as I mentioned before, and save the clean data as fars underscore proceeded dot CSV. The goal was to transform a raw federal data set into something a machine learning model can understand. I decided to use a random forest classifier. I chose this model because it handled mixed data types, numbers plus categories. It worked well with messy real world data. It handles imbalanced classes, better using class weights. It provided clear feature importance values, and it performs well without needing complicated tuning. This made it a perfect choice for a project using government crash data. I trained the model using a 80-20 test split. I used the random forest to use 250 trees and balanced class data weights so the model wouldn't be biased towards the majority class. During training, I printed out the classification report so I could compare precise, recall, and the F1 score for both severity classes. After training the model, I checked how well it performed. I generated a confusion matrix and printed an accuracy score. Based on my evaluation, lightning conditions were one of the stronger predictors. Rural road tended to have higher severity. Nighttime crashes were more likely to be more multi-fatality. Winter months had slightly higher severity in certain states. The conclusion matrix slide shows how often the model correctly predicted each class. For the demo part of this project, I built a simple Streamlit application. In the real app, users would choose hours, months, nighttime, winter, and the model predicts whether the severity is likely to be low or high. Since I can't run Streamlight inside the slides, I included a screenshot in exactly what the UI looked like and how the model responds. Okay. Let me show you my demo slides. Okay. So this is the confusion matrix output. This was the terminal model training output, and this was the Streamlight app indicating app prediction screenshot. And then I'll go back to where I was. Okay. As far as limitations go, um, okay, in conclusion, so to summarize, I used the official federal FARS dataset, clean and encoded the data, built a random forest classifier to predict severity, evaluated the model with a confusion matrix, created an interactive Streamlit demo to show predictions. This project helped me practice real-life world data cleaning, featuring engineering and model deployment concepts. Thank you so much for your time and thank you for listening today.